All right, let's discuss about common pitfalls with the usage of Karpenter and what you need to take care of when you start working with Karpenter. First one, insufficient time permissions. One of the common mistake is not configuring IAM roles and permissions properly. Karpenter needs sufficient permissions to provision and manage nodes through AWS services like EC2, Autoscaling, and IAM. Missing permissions can result in node provisioning and node provisioning failures or delays. You can use the Karpenter provided IAM policy templates and attach it to the Karpenter node instance profile. You can just follow the documentation. They have given pretty good details on the website. Over provisioning resources. Another pitfall is we often see is over provisioning the resources. User often set high CPU, high memory request limits, resulting in underutilized nodes or unnecessary expensive EC2 instance types. Ensure your pods have realistic and balanced resource requests and limits based on the actual workload requirements. That way you will help Karpenter to create the right nodes. Number three, ignoring spot instance behavior. So using spot instances without understanding the interruption risk is another common issue. Spot instances can be terminated without notice. Yeah, technically they give 2 minutes notice, but that's not enough for most of the cases, which may disrupt your workloads if you are not prepared. So use tolerations for spot instances and design workloads to be resilient to the interruptions. For example, using deployment replicas or queue-based system. Karpenter also provides an SQS queue where you can push these spot instance notifications through event bridge, and Karpenter can look for that, and as and when it sees that, it can proactively drain the node and create new nodes. That can be done. Number four, lack of taints and tolerations. Failing to configure taints and tolerations can be can lead to scheduling inefficiencies. For example, for critical workloads might end up on nodes meant for lower priority workloads, right? So this can happen. So you need to make sure you have the proper taints and tolerations. Number five, not optimizing node consolidations. By default, Karpenter consolidates nodes to optimize for cost, but users sometimes forget to enable or configure it properly through the node pool configurations. This can lead to over-provisioned clusters or wasted resources. So enable and configure consolidation policies to allow Karpenter to downsize underutilized nodes automatically. Number six, misconfigured node pools and node classes. Improperly configured node pools and node classes can result in nodes that don't meet workload requirements or that are too expensive. For example, using large instance types unnecessarily or missing the zone constraints can cause inefficiencies. Define clear constraints such as zones, instance types, and networking configuration to match your workload needs. Number seven, ignoring scheduling constraints. Finally, users often forget to account for pod level scheduling constraints like affinities, node selectors, topology spread, very important. This can lead to pods remaining unschedulable even when nodes are available. So you should review and align your align your pod specifications with Karpenter's node pool and node class configurations.